Hi, Assalamualaikum. Today our group would like to present about Lab 5, which is particle count. My name is Muhammad Faiz bin Rosli. Okay, I would like to present about the introduction and objective. Okay, for introduction, the importance of clean oil cannot be ignored in any machinery system. Any machine components that experience contact and friction will generate wear debris regardless existence of lubricants. Particle count data is an invaluable part of proactive condition monitoring program. The particle count data can be used to ensuring that components wear is at minimum and determine if a hydraulic fluid is clean enough for reliable operation. The International Organization for Standard ISO has developed cleanliness code that is the primary piece of data review on most industrial oil analysis report. The value of this code can help determine the overall cleanliness of the monitor system. The cleanliness code is regulated in ISO standard. Number of particles in 3 different size category. For example, 4 micrometer, 6 micrometer and 14 micrometer. Alright, for the objective in this project is first to observe particle contamination in lubricant sample. The second one is to classify cleanliness level of the sample.
Assalamualaikum and greetings to everyone. My name is Muhammad Fida bin Abdul Ghani. I will present the procedure of particle count by using the Parker-less CM2 contamination monitor. So particle count is to measure the cleanliness level of the oil. So by measure the cleanliness, we can know the cleanliness level for safe operation of the machine. So the particle count is referred to the ISO 4406. This ISO we present the ISO code that will indicate the cleanliness, the level of contamination or cleanliness level of the oil analysis lubricants. So first of the experiment, set up all the equipment and sample. So the equipment are Parker-less CM2O contamination monitor, which is the equipment to testing or to measure the cleanliness level of the oil or lubricants, and UBS degazing chamber and pump. So UBS degazing chamber function, chamber and pump function is to remove gases from the compound which become entrapped in the mixture when mixing the components. So for example, in the sample may have gases, bubbles, air bubbles that may contribute to that can affect the result. So by using the UBS degazing chamber, which will pump out degazing chamber and pump will pump out the gases or air bubbles of the oil in the sample. So next, heptane use is to clean the residue in the residue of oil in the machine after the testing testing of the equipment. Next is the sample. A sample of lubricant can be anything. And next is empty bottle. Empty bottle is used for the drainage point of the testing. So first of all, first step is, so the first step is insert the oil sample in this degazing chamber, and on the machine uncap the oil sample and then insert in the decasing chamber. So and then on the pump. After switch on the pump will pump out all the air trapped inside, pump out all the air trapped inside the sample. Wait until all the bubbles are gone. Okay. Next, okay, we will test, starting the test. So starting the test, put the after the decasing chamber process, put the sample in the UBS in the UBS in the UBS offline Parkerless contamination monitor. So after put the sample will put in the suction the sample will put in the suction tube, while the empty bottle will put on the discharge tube, and switch on the UBS offline equipment, and then press on. Next, set up starting input the parameter of the CM20 parameter setting of the machine. So after press start on the UBS offline suction and discharge tube, after inserting the oil sample and the empty bottle, so refer to the screen of the laser CM20 and then press mode. Switch on the laser CM20 and then press mode, and then select ISO 440C199. So after that, next, okay, starting the test. To starting the test, observe the arrow on the. Okay, next is the starting of the test. So to starting the test, observe the arrow on the knob of the CM20 laser equipment, and rotate the knob to 90 degree clockwise. So the testing of the particle count will start immediately. So and then wait for 2 minutes until the testing finish. So when the testing finish, the screen of the CM20 laser will show the ISO code of the testing, result of the testing, and then ISO code will display on the screen laser CM20, and then press mode to show the result. So after press mode show result, and then record the result, record the testing, or record the data of the result from the testing, and then so actually the data should be run should be repeat, so to get more result and better analysis to repeat the analysis, just rotate the knob 90 degree clockwise, and then the testing of the oil sample will start immediately by refer to the parameter by using the previous setting parameter parameter of the equipment So and wait for until until the testing is finished for exactly 2 minutes and record the second data or result. Okay, after running after finish the testing of the oil, so is the post cleaning process. So function of post cleaning process is to remove or to remove we need to make a post cleaning process. So post cleaning process important to avoid to remove all the oil residue in the UBS machine because when testing of another sample in the future, the result will not affected by the previous testing. That's why we need to post cleaning of the post cleaning process. So the state of post cleaning process is flushing. So flushing is the process to drain out all the remaining oil sample in the UBS offline. So like I mentioned before, to avoid the sample, the result of the sample affected by previous testing. So to make the flushing process, first put the empty bottle in the drainage pipeline or drainage point, and then press flush. So wait until the flushing finish, and then repeat the step of flushing by using the N-heptane. Okay, N-heptane. So to flushing by using the N-heptane, put the N-heptane solution in the suction pipeline, and the empty bottle remain in the position of the discharge pipeline. So press the flush button. So after press the machine will process the N-heptane and we flow in the machine, and we clean in all residue of residue from the oil analysis before of the oil analysis testing, and we clean the residue of the oil, and then we'll push the residue into the empty bottle. So that is the flushing by using the N-heptane. So after all the testing and the post cleaning process is finished, switch off the laser CM2O, and then switch off the UVS offline, and then switch off all equipments. So to analyze the result of the testing, so to understand the result or obtained from the testing, we need to refer the ISO 4406. We represent the particle code or particle count, and discuss the indication of code represent. The code represent is will show the cleanliness level of the oil, and then measure what is the oil cleanliness level indicate. whether the oil is safe for operation or not. So mostly the result, this testing of the sample lah, mostly start with your new oil sample, and then repeat the process of testing by using the contamination, the used oil lah. So by comparing the both result, we can know that how contaminants, the volume of contamination itself. For example, the rate of the contamination compared to the new and the used oil lubrication. So the important of the analyzed data is the ISO code, and then you can compare with the two testing sample, used and new, and then analyze the factor that affect the contamination, referring to the standard or the product certification. So after the setting finish, we can know the cleanliness level of the oil and know the contamination of the oil. As that finish, thank you for the that's all the procedure of the testing by using the CM2 level, CM2 by using the Parker laser contamination measure. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Falah Aiman, and I will explain about the results. So, as we can see from the experiment, we use two types of oil, which is one is fresh hydraulic oil and second is used oil. For sample fresh hydraulic oil, the particle count in 4 microns for repetition 1 is 835, and for repetition 2 is 696, and for third repetition we got 754 particle counts. So from three of the results, we have to calculate the mean and the standard deviation of the sample. So the mean for 4 micron is 761.67, and the standard deviation that we have calculated using standard deviation formula is 69.81. So the ISO code classification for the sample 4 microns is 70. Move to the 6 micron. Repetition 1 we got 339, and second repetition we got 268, and the third repetition we got 296, and the mean is 301. The standard deviation is 35.76, and the ISO code classification is 15. Lastly, for the 14 micron, we got for the first repetition we got 32, the second repetition we got 35, and the third repetition we got 37, and the mean for the oil is 34.67, and the standard deviation is 2.51. ISO code classification for 14 micron is 12. Move to the particle count for used hydraulic oil. For tank in hydraulic oil, used oil, we use two tanks. First is tank A and second is tank B. For tank A, the 4 micron particle count we got 1375 for repetition 1. Second repetition we got 1281, and the third repetition we got 1348. So the mean for the particle count is 1334.67, and the standard deviation is 48.39. and the ISO code classification is 18. For 6 micron, we got 509. Second repetition, we got 428, and for the third repetition, we got 440. So the mean is 459, and the standard deviation is 43.71. The ISO code classification is 16. So for the particle count for 14 micron, we got 152 for first repetition. Second repetition, we got 165. Third repetition, we got 153. And the mean is 156.67, and the standard deviation is 7.23. ISO code classification for 40 micron is 14. So for the sample in tank B, for 4 micron, the first repetition we got 2,750. For second repetition we got 2,562. And for third repetition we got 2,696. The mean for 4 micron is 2,669.33. And the standard deviation is the standard deviation is 96.79, and the ISO code classification is 19. And for 6 micron, we got 1,018 for first repetition, and the second repetition we got 856, and the third repetition we got 880. The mean for 6 micron is 918, and for the standard deviation is 87.42. So the ISO code classification we got 17. For 40 micron, the first repetition we got 304, and the second repetition we got 330, and for the last repetition we got 306. So the mean we got is 313.33. Okay, for the standard deviation, we got 14.46. The ISO code classification for 14 micron is 15. Thank you.
This is Muhammad Azmil bin Muhammad Arif, and I will continue the presentation in the discussion part. There are few topics that was discussed in the discussion. And the first topic that was discussed is the assessment of the level of cleanliness of hydraulic oil samples in tank A and tank B. The most common standard used to rate cleanliness is the ISO of 4406. These ISO codes used to represent the number of contaminant of particles present in 1 milliliter of oil. The level of cleanliness of oil samples can be determined by 3 number codes related to the number of particles. There are 4 micrometer, or commonly pronounced as microns. So 4 microns, 6 microns, and 40 microns. Therefore, the result is for the sample from the tank A is the ISO code of 18/16/14. Meanwhile, oil sample from tank B resulted in ISO code of 19/17/15. The oil sample in tank B have higher particles counted compared to oil sample in tank A. The second topic that was discussed was the relation of the particles counted to the quality of the oil and the performance of machine components. As we know, particle count determines the quantity of particle in specified micron size range. Particle contamination can interfere with the oil performance and therefore will affect the overall machine's component's performance. target ISO cleanliness code can be established for each type of equipment and machine components. By reaching the desired ISO codes, sustainability and operability can be improved. Failure to reach the target ISO code can result in shorter life for both the oil and the machine components. By continually monitoring ISO code, you can adjust your maintenance practices to achieve your desired cleanliness goals, thereby improving your equipment uptime. And the last topic that was discussed was why number of particles increased on used hydraulic oils. The number of particles increased on used hydraulic oil can be caused by ventilation, seals, regeneration, and contaminants. For ventilation, poor ventilation can cause outside or dirty air entering the system, therefore affecting the oil particles counted. On wear generation, some particles measured during particle count may not be strictly contaminants from outside source, but rather the effect of this contamination in the form of wear debris. In filter, dumping or bypass system inbuilt-in filtration may run dirty because of operation condition or flaw in design. In this case, all the particles that are being caught by the filtration system are being sent through the internal components, therefore increasing the particles counted of the oil samples.